This topic's known as iteration because basically we put one value into a formula and we get a new value that pops out. And this n means like our nth term, and then the n plus 1 is the one after that. So let's demonstrate by having to get this question. We've got that u1 is 5. I mean, n essentially would be 1 in this case. And if I put that in, then I put 1 into here as well, and I'll get u2 out of it. So all I need to do to find u2 is do 2 lots of u1 plus 15, and then I can substitute that in. It's going to be 2 times 5, which is 10, plus 15. That's going to be the square root of 25, and that's equal to 5. Okay, and in theory, you could construct a sequence. You could put that back in, and that actually, in this case, it's going to stay the same. So this, sorry, I just realized that. This sequence, if it was 5, would be just 5, 5, 5 forever. But if we have a different starting value, then you get a different sequence coming out. Another sequence is defined using this rule. Okay, this time we don't know what k is. Interesting. K and r are constants, and presumably we're going to have to find them. Yes, we are. But we're given some of the terms in the sequence. So I can write down that u3. So I can sort of let n equal to 2, and that will mean I've got u3 here, and that will equal k times u2 plus r. Does this help? Yes, it does, because I know what u3 is. It's 206. It's equal to k times 41, which I'm going to write as 41k plus r. So I've created an equation. I've got k and r in it. I don't know what those are, so I'm just going to have to roll with that. That's all right. I can do the same with u2. I'm just going to write it over here. u2 will equal k u1 plus r. And I know what. Oh, sorry. Okay, I don't know what u1 is, but I can change it to u4 will equal k u3 plus r, and then I can substitute this in. So 1031 must equal 206k plus r. Created another equation. Well, actually, what I've created are simultaneous equations, and I can deal with this in the normal way that I deal with simultaneous equations. I can, in this case, I've got numbers on the left, but that's okay. You know what? I think I'll just be a bit careful. First thing I'm going to do is I'm going to write the bottom one on the top, but I'm going to switch it around. And the only reason I'm doing this is to make it a bit more. This is how you normally see them when you get a simultaneous equation sort of question. So I've written this one, but I've just swapped it around and written it at the top, and I'm going to do the same for the other one. Just swap it around and write it now below. And the reason I've done that is that now it's going to be, first of all, they're in this sort of normal format, and secondly, the larger numbers are on the top, so I'm not going to get any negatives. And now I've got r is the same throughout, so I can subtract the left-hand sides, and I can subtract the right-hand sides. And the reason is that these will cancel, and I'll be left with 206 minus 41, which is 165. Okay, and that will equal, I think I'm just going to resort to a calculator, 1031 minus 206. That will equal 825. And that allows us to find k. 825 divided by 165 will give us k, and we get 5. Nice whole number. Does it say? It doesn't say it's a whole number, but I like the fact it's come out as a whole number. It probably means I've not made a mistake. So now it's what we normally do with simultaneous equations. We just substitute back into either one. Sub back in, and I could choose either one. I could even check both. But 206 will equal 41 times 5 plus r. So 41 times 5 equals 205. So actually it's going to turn out, let's show it working. 206 will equal 205 plus r, and r is going to equal 1. If we just check that with the other one, then 206 times 5 equals 1030, and if I add on 1, I get my 1031. So I can see that these numbers work for both equations. I must be correct. It's a simultaneous equations linked into this iterations question, and we've done it.